I'm going to show you a Vert.x application, but which is using the Mutiny bindings. So the Mutiny bindings, we maintain them separately, like they are made for Vert.x, but they are not part of the stack of Vert.x because we still need a different release space right now. So they are developed separately in small array, reactive right now. And just like in the stack for the bindings of Java, for example, or the Kotlin coroutines, we use code generation to generate the bindings for all the, well, not all the modules, but the main modules you may want to use in Vert.x. The only difference is not an io.Vert.x dependency, it's an io small array reactive dependency. And instead of being, say, Vert.x web is going to be small array Mutiny. And you can see, yeah, again, you have all these modules, and my completion is not complete because I have a Kafka, I have, all the stuff you may want to have. So again, let's create a basic Vert.x application, but now with Mutiny. So to do it, I'm just going to take my class. I'm going to say this is a vertical. So I'm too tired and it's Friday. So if you haven't read the book or you don't know Vert.x, a vertical is the unit of deployment. So it's what you deploy in Vert.x to process asynchronous events. I would say it's the asynchronous component you want to deploy. It's not an EGB, let's say it's an asynchronous EGB. And I'm sure I will make friends by doing so. So I have my Vert.x context. So I'm going to create it. I'm going to deploy a vertical, like I deploy main, or I use main. I'm going to give a supplier because it's a bit, oops. And is not happy. Why? I don't know. Okay. Like this. Okay, so I'm going to do it differently because now. Okay, so I'm just going to do main like this. So IntelliJ is happy. So that's my vertical. That's what I'm going to deploy. And then I have a fairly simple programming model. And because I'm using the Mutiny bindings, the start method is called async start, and it returns a uni. So the uni, oh, thank you, Tinibik. I don't know if you're Julien or anybody else, but like, yeah, you need deployment options if you pass a supplier. So it should be something like main new, correct? And new deployment options, oops. Deployment options, and then, okay, you pass a supplier, and maybe I can say something like, I want to set instances. I want 2 instances, like I'm going to deploy this vertical twice, for example. So let's start. I have Vert.x, and I can do something like a periodic timer, like every 3 seconds, I'm going to do something, and this ID like this. I think I need a logger because logging it's important if I want to show you what happens with threads. So I'm going to do log.info tick like this, and then I can return Vert.x.create HTTP server request. So that's my request. So I'm going to request.response.end, and forget to say, I don't want, because it's an asynchronous operation, so I just want to end and say hello like this, and replace, oops, and listen, because I want to listen on a port, and replace with void because I don't care about the HTTP server object. So by doing so, I should have a service which is running. So if I run the service, let's just see what happens. So I will have 4 instances of, oops, what went wrong? So, okay, I'm going to get back to something that I know works because the demo gods are not with me today. Oh yeah, I know why. Because I need to subscribe because it's Mutiny. So it's not the same. So I need to subscribe with the consumer to say, okay, and I do nothing because I don't care, and it should be working this time. Okay, so you can see that we have every 3 seconds we have a tick. It's running on a Vert.x event loop thread, so a thread which is tied to the event loop which you're running. And if I do an HTTP request, then it should tell me hello like this. I do a few requests, and if I look into my logs, you can see that I'm going to stop it. You can see that it's all running on the same thread. To show you this, I should have put a log here to show you what happens with the threading when I process the HTTP request. So request, nothing too fancy, to be honest. So I'm going to do this, make a request, a few requests, and you can see that, it's all been working on the same thread like this. Okay, so that's Vert.x, but, with Mutiny APIs. We're going to switch to the Mutiny SQL client. So how do I talk to a database with Vert.x? So I'm going to talk to a Postgres database. So just to make sure you understand what's going on, so I have a main method here, which is more or less the same. So I create a Vert.x object. I deploy and I pass, references to my database, so you can connect to it. The only thing is I'm using test containers here because for the development purposes, it's nice to have a container started for you. So I could use Docker on the side, like Docker Compose, to start the Postgres database. But here in this case, I just want to do it for my code. In the case of a demo, it's really great. So I'm just using Postgres test containers, sorry, to start my database, and then when I start my application, it will start with a database for me just on the side. So you can try this kind of thing, and I will talk to you about how it works in Quarkus. In Quarkus, you have something like this, which is very new, which is called the dev services. So you can see that it's been more or less most of the bulk of the time was to start the container, and then Vert.x itself, it starts really, really fast. So if I show you this, so if I show you this, what this service is doing, you have an API, you can have products, like I can post like a baguette, and I say the price is 90 cents, which is not the correct price anyway, but I know all the French people will hate me for this, but it's an API, and basically these products, they are stored into a database. So this is with Vert.x, pure Vert.x and pure SQL client. So how it works? So when you start, so you need this thing. So PG pool, it's your pool of connections to Postgres, because I'm using the Vert.x Postgres SQL driver. So to connect, I need a connection object to tell me what's the host, the port, the name of the database, the user, the password, which is a nice password anyway. So I have my pool, and I get I create my pool like this, and then the rest of the code here are just the HTTP API using Vert.x Web. So products maps to this method. Fetching a product by ID, this method is a router basically. All the products is this method, etc. And then you start the HTTP server. So it gets more interesting when you get to here, like this method, list products. So what you want to do here is list all the products in the database. So it's a very classical select star from product query. So with the SQL drivers of Vert.x, you do it like this. So you have your pool of connection. You can do stuff like queries, prepared queries, transactions if you want to, etc. So you do a query, you execute it because there's nothing to pass. When you have an item, which is a row set, so a bunch of rows from the database, I construct a JSON array with all the responses, and the responses are just the rows in JSON. There are ways to make it simpler, because in row set, there's a now it's another edition of Vert.x, sorry. But yeah, anyway, we have shortcuts if you want to do it more quickly. I have also an on failure to say to recover and just give an empty array if I have an error, like my database is down. So we just respond with an empty array. If I go back to another method, so create a product is when I want to insert into my database. So what I'm doing, I'm extracting things from the HTTP request. In this try catch, I'm doing some extraction and validation. Like I want to check if I have all my keys and if they're correct, and there's no issue extracting. If ever it's the case, I just return with a uni with the failure because I need to return a uni there. And then to do the insert, I have a prepared query. I insert with some placeholders, $1, $2. To pass the name and the price, I have a tuple, which are going to be my values for $1, $2. And then, you just have on item on failure and you do your stuff. So this is a very simple way to deal with SQL databases where you do SQL. And again, if you do SQL by hand, it's not bad, it's not dirty, it's very simple actually, because you can do lots of things with plain SQL if you like it. I'm going to switch now to the example. So it's going to be the same API, still with Vert.x, except that now I'm using Hibernate Reactive. So I'm changing the programming model a little bit. And I'm going to show you what you need to make it work. So I could run the product, the service, but it's going to be exactly the same thing. The same endpoint, same HTTP queries, you get your stuff in the database, etc. Instead, I'm going to show you something which is more familiar to many people, and that's an entity for Hibernate. So instead of manipulating pure JSON and row sets in my database, I'm going to map to have an entity which is a product, and this is going to be mapped to a table in my database by Hibernate for me. So what you have here is a product with a primary key, which is your ID, a name which is unique, a column here which is the price, which cannot be null, etc. So this is traditional Hibernate code you may be doing. This is a very typical entity with some getters and setters, etc. What's important is this, like your very classical entities. So to make it work, when you get to your object here, first thing you need is a session factory. So that's your session factory from Hibernate, and you have different variants. So this one is mutiny.session factory. There is completion stage.session factory. It depends which asynchronous API you want to use, but that's your entity management session factory. So I'm going to create this. So I just need to tweak some of the configuration of Hibernate. We'll get back to it. So don't be fooled with this JDBC for the persistence URL. It's just to reuse the configuration that exists in Hibernate. But when you do this, and we have reactive, as we will see, it's not going to be JDBC. It's going to be the Vert.x SQL driver of Postgres. So I'm just doing this because I need to override the configuration, because I'm using a test container or a database in test container. Then I just create my my persistence unit, call it the way you want, as a session factory, and then I'm just ready to go. So this is again the same code for the HTTP API. Nothing really fancy. And then if I want to list the products, so whereas in the beginning, well, in the SQL version, we had to do the SQL query ourselves. In this case, we go through the session, and with the session, we create a query which is from product to give me a product class, and we get the list, and that's it. So we get a uni of list of product, because fetching from a database, it's a one-shot operation anyway. It's not a stream, right? Databases don't stream. It's something you should remember. So we get a uni with the list of the products. And here I'm not doing SQL, I'm just using Hibernate, which, same thing here if I want to store into the database. So I'm using the session, I'm persisting the product, which I just built here. So I have my bean, I create my bean, I fill the values, I persist. Then chain, it's a shortcut for onItem.transform to uni. It's a Mutiny thing to chain asynchronous operations in a nice fashion. So you flush to your database, and then because you want to respond with something, you just put back the product, which is going to be mapped then to JSON. And same thing if you want to find something by ID, you have session.find, etc. So you have a bunch of queries, methods in Hibernate. But the cool thing is you are using Mutiny to deal with the asynchronous nature of the operations. The last thing I need to show you here is how you configure it. So you still need this persistent.xml file, which is here. This is a very typical persistent XML file, nothing extraordinary. We just say that we are going to use the reactive persistence provider of Hibernate. So it's Hibernate reactive. And then in the configuration, nothing else. You just, you say if you want to have logging or SQL queries, you give the password to the database, connection parameters, etc. So then it's plain Hibernate. And you can use it in Vert.x applications. So again, you can have pure SQL, you can have Hibernate reactive if you want to. And a great addition in Vert.x 4 as well is that in the Mutiny bindings, and it's because in Vert.x Web, we have the 90s now, you can return the asynchronous operation rather than having to subscribe to the uni. So it's because we use in the Vert.x router, we use respond. So it's a new thing. It's not covered in the book. I didn't talk about it because it's fairly new. In the book, I showed you handler. Like it's what is being called when I want to deal with this endpoint. And in the case of Vert.x 4, now we have respond, which basically in the case of Mutiny is going to subscribe for you. So you provide a uni, like in the method you have here, you provide a uni, and when you have your HTTP request, it's going to be subscribed for you. And by subscribing, it's going to trigger the whole operation of talking to your database and giving the response. What you have in this service is more or less what comes packaged for you in Quarkus, but I will show you some other goodies in Quarkus. I see that I'm still going to run this service because I just want to show you that it works. So again, I'm starting Postgres. It's really the thing which is going to take time. Like starting a container is not a cheap operation. Then you have Hibernate, which is kicking in the beginning. It's been creating the table for me. Again, it's a nice kind of experience. Vert.x itself is fast to start. And if I do HTTP like this, so I put a baguette in my database and I get all the products, you can see it works again. So that's Hibernate and Mutiny. And the last thing that I wanted to show you is basically this code, but in Quarkus. Like in Quarkus is going to be what we did here is more or less what Quarkus is doing with all the bits, like the HTTP endpoint written in REST is reactive, as we will see, talking to the database using the Hibernate reactive, etc. So I'm going to start with this. So that's my Quarkus application. Like I'm going to run it so you can see. So when you do Maven like this, Quarkus dev, it's the Maven plugin for Quarkus, and the nice thing is it manages hot reload for you, automatic reload. And in this case, it's also starting using test containers to start a database for me. There's a configuration to do that. But in development mode, if you don't want to start a database on the side by yourself, you can just let Quarkus do it for you, and everything is managed for you. So that's pretty nice. If I do just a few requests just to make sure it works, products, I have nothing. I put a baguette and I get all the products. So yeah, it works, which is always good. So if you want to, you can use Vert.x, plain Vert.x, like a Vert.x context if you want to, and manage HTTP endpoints with Vert.x, but you might as well use REST-easy reactive. So it's REST-easy, that that familiar programming model, which is based on a notation. So it's not a router like in Vert.x, which is great as well. I like it, but REST-easy, it's another annotation-based model, and you define your endpoints. Like if you want to get all the products, it's a multi of products. You do add, get, etc. So that's this programming model. I don't need this actually. The path param in REST-easy, I don't need it because it's going to figure out by the name of the parameter in the query, so I don't need it. And because there is hot reload, it should be done for me automatically. So I just restart. I don't need to restart. I just let Quarkus do its thing, and it works. So that's REST-easy reactive, but under the hood, it's using Vert.x. So you still have the same. You still have the power of Vert.x in it, and then the only thing that I did a bit differently in this case is using so you can use Hibernate entities just like we did in the other example, but there is something in Quarkus which is called panache. I know it's a French name. You can define your entities, but using the active record pattern. So if you've done lots of Ruby and Rails, you know this pattern, but you may know it from other technologies as well. So the idea is that you define your entity like this. You don't have to define all the getters and setters and stuff like that. You just say, I have a name, I have a price. You could also say it's a primary key if you wanted to. And then you have factory methods like all to do the stuff for you. Find by name, so you do find. You say my query is going to be on the name, and you pass the name and you give the first result. So with panache, it's even more compact. You write some more compact code and you get tons of nice helper methods for you. And it's also using Mutiny. So really, all I have in this example is a REST-easy endpoint, a panache entity, and it's all assembled into a framework, which is doing more or less again what we did manually with Vert.x. I think it's interesting, especially if you're a Quarkus user and you want to understand reactive. Using the Vert.x gives you an idea of exactly what's happening in this magic that you have in a framework, because a framework is always a bit of magic and things that work magically together. So it's interesting to understand it.